So far, so good. Means whatever we saw in a cull facing, and then changing the kind of the rotation like clockwise or counterclockwise of the vertices. So it was interesting. It means we could see that we can optimize the Opengl to draw or to cull the back side or to cull the front side, and it was interesting. So this is what the end that is intended from us. So certainly not. So we are kind of looking for more. So this is not the only reason someone would enable the culling and just to show the back and front. So anyway, nothing undesirable. Means so we can kind of whatever we were doing. So only thing is if I don't cull the back side or front side, the computation would be more from the Opengl side. So it is optimization. Okay, so if it's a graphics, right, at the end, and if we are getting the frames at regular interval, what we are expecting, or 15 frames per second or 30 seconds per second, then no one mind. Means okay, let the Opengl do the work. But problem happens more. Means this is not the end. The way we are discussing, there are severe problems that we are facing. Like if I am showing moon, or if I am showing a moon on the moon from the earth, or earth from the moon, and then if it is not the sunlight is not a kind of it is going to fall perpendicular to the moon or earth. If it falls perpendicular, then full earth or moon would be visible. It would lit full. But what about if it is coming from the angle? Then kind of if it is complete, if I say it is 180, then 150 degree or 120 degree or probably 30 degree or 40 degree, 45 degree, that much only would be shown. Other area should be invisible. Means it should be transparent. I cannot say the other area should be the ambient color. So I mean, what I'm trying to show is, if the moon is first day to 14th day, and 7th day it is half the moon. Okay, so prior to the 7th day, 3rd day, 4th day, so it is like a crescent moon. If it is a crescent moon, then other part of the moon we cannot see. Means it's a transparent. We see the sky. So I cannot go with the ambient color. Generally, this is what we do. If light is falling on a surface and the area that is not falling on the light, so that will be ambient. So how we set the ambient to a transparent? I mean, there are ways that we can make the other area transparent. That is the solution. Means this is what we will do in the shader programming. We will change the shader code, and if light is falling and the area that is not under the light, that is the ambient area. Anyway, ambient color we can draw completely on the sphere, but the particular area that is only ambient, emission anyway will set it to 0. So only ambient, those areas will set it to kind of a transparent. Okay, but it doesn't work, unfortunately, because if it is a sphere, then if I front side, if I set it to transparent, then it is seeing the back side. Okay, this is a sphere. Okay, from my side, sun is there. The front side, some portion is transparent. So sphere's back side, okay, that portion is so there is a depth test. So back side should not come into the picture at all. Means they are anyway behind the scene. But since some area I am making transparent, it will show some kind of weird kind of color. Okay, that is the problem. So that is something that we need to cure it. Means this is not something that we need for optimization. It is something we need kind of for particular functionality, particular feature. So if the moon, what we are showing is the 3rd day or 4th day moon, the rest part, the front part we are showing as transparent. If it is transparent, then back side it is showing some weird kind of color. So first we will see the problem, that what is the problem. Then we'll see that how we resolve it through the shader programming. Still, we are not able to resolve through the shader programming. So beyond the shader, once we receive the fragment, color fragment, and then it is passes to cull test, the phase test. So there we'll do the math. So scenario is whatever we have showed now. So certainly this is not the end. Okay. So we will see more on. So that will see. Okay. So we'll proceed on cull phase. So the way we have discussed that it has anomaly and it is not that smooth. What we showed that we just do things and it works. So we'll create a scenario like okay. So I think okay, so I'll bring back so of FGL whatever we have done, and now this is what we showed. So for knobbing, we'll kind of comment these lines, culling, and then we will have kind of one light source. So nothing we need, and there is one light source. So this light source would behave like a light source and object both. So we have people who are following our Opengl to keep following. So we are kind of we have a software and we are developing it, and as per the discussion, it will have machine learning interfaces also down the line. So we can specify ouch file. So this is what we are looking. Okay, so it will have a material characteristic. So I'll say material diffuse equal to unknown. So if it is a kind of unknown BAO, non BAO, then we'll set. So we'll set it like white color. Material shininess equal to -1. So we are creating a small sphere, okay, and okay, so there is no meaning of material ambience here. Light position is correct, so it is at 2. Okay, and light diffuse. So earlier it was a red light. Okay, now it is a white light. So that is concept. And then we'll set the transformation. Transformation equal to 002. So this big it would be. Okay, so can someone believe that we have created a light source which has a position and diffuse color, and then we have created a material also, model also, which has a transformation, means position, and it is a sphere, so it's a round, and its diffuse color is 111. So okay, diffuse color, okay, so diffuse color is white. So this is a white sphere. Now we'll have one more. So whatever we had, which has diffuse color as green, and it is shininess, it will have a shininess. It is not a light source, and it will have a transformation. So that is at 0. So no transformation is required to set. Okay, and that's it. Means what a software. Means we created a kind of one light source and one model here together, and now we have a object sphere and which is green and it is size as 1 default, clear color 0, smooth and depth. So we can start right away. Okay, so this is what it is. So white color is light source and green sphere is what we are seeing. So light source I am going to move, so we can see that light is, we can see difference. So this is ambience, whatever the black part, the shadow part we are getting, this is ambience. It is nicely mixed with the surrounding, so not required. So if I want to emulate kind of a moon, okay, then we can emulate. Now see, now we have crescent moon. So crescent moon is, now light went back. I mean I shall try if I can rotate it all together. Okay, so this is the rotation altogether, and if I consider the right side as z-axis, then white is this much in the negative direction of z-axis. Okay, so this is the situation. Now if I want, then kind of I can make a crescent from the down also. Okay, so we have crescent moon and it is kind of from the down we can make a crescent moon. Okay, so from up we can make crescent moon. Okay, so this is how it is. So what is the problem here? Problem is it's not a sky. It is not a sky. Okay, so that is the problem. I believe I can increase a little bit light. So light position, light diffuse, I'll make it 2 so that it will glow more. Okay, now I am going to GL clear color background as a sky color. So it will be like 135 by 255. This is the sky color. 206 by 255 and 235 by 255. So this should be a sky color. We'll try again. This is really a sky color. Now I am going to move this, and now it is not desirable. Means if I bring it down, and now I'll try to make it crescent. This is crescent moon, but this is what we don't want. Means this is really crescent, but this is black, but sky. So it should be transparent. Means someone should see the sky when moon is like this. Okay, so if moon is like this, then this should not be black. Okay, so ambience, we have to make our ambience color will set the way the sky is, but still that is not the solution. It should be transparent. Okay, so that is the issue. So we'll make the shader code, we'll modify the shader code and we'll make it transparent. Okay, so that is what we want. Okay, so we'll change so we are ready to change the shader code. Okay, so we'll go to fragment shader and we'll introduce a variable here. Okay, so certainly it is not a varying variable here. Okay, so like float ambient T. So this is ambient transparent, and now we'll go down and we'll introduce a calculation. So here we'll have a calculation. So ambient T equal to light I dot ambient into material dot ambient. Okay, so whatever the material ambience is into light ambience, this is the actual mathematics. And if dot Ln greater than equal to 0, so if light is falling directly, okay, that is diffuse, so there we don't want our ambient, so our calculation will kind of take it back and will say that you are 0. That's it. And in the calculation where we do the ambience calculation, we can see, so light I, so we can save it rather than modifying directly, and light I into, anyway this we have set it, so we'll say it as ambient underscore T, because anyway we are doing the calculation. Okay, so if light is falling directly, okay, dot Ln greater than equal to 0, then ambience we are setting it to 0. Now here in the shader code we do like if material shininess is less than 0 or light, there is no light, then we go for kind of direct calculation. Otherwise we carry on the calculation what we have done. Okay, so here we'll modify. So that is the science. So here I would say if ambient T equal to, so if there is a direct light, if there is a direct light, if there is a direct light, then fragment will calculate the way it is. Otherwise we will do kind of smartness. So frag color wake clamp 0, and here we will say tata bye bye. Okay, so we'll force that it should be have a kind of 0.0, so there is no kind of, so it's a full transparent. So if light is not falling directly, if falling directly, then ambience is 0. In that sense, do whatever you are doing. Otherwise, make it transparent. Okay. I believe it should be alright. Now we'll go ahead and then we will, whatever we have done, so we expect that it should work. Now, okay, so we'll introduce a kind of blending. Since we are doing transparency, so there will be blend. So we'll implement like GL enable, GL blend, and here we'll have GL blend function, GL source, and for destination it will be GS source alpha for source, and destination is GL1 minus source alpha. Okay, so GL enable, GL blend, and GL blend function is GL source alpha, and GL1 minus source alpha. Okay, So we'll try. No one stops us trying. Okay, so I think it is alright. So we'll try now. Mr. Shader should compile and it is not compiling. Okay, what is the problem? Frag shader. Error wake 3 cannot assign variable type a float. So we have done some nonsense. Okay, so Mr. Ambience is wake 3 and it is not float, and then ambience t we are calculating nicely, and dot L greater than 0, then ambient t is wake 3, and then here we are comparing, and then we'll try again. Oh, now we expect that it should be transparent, again black, so we'll set some ambience, then only it will detect. Okay, so we'll set some ambience. So this light will have some ambience, light diffuse, light position, light ambient equal to something we'll set, light ambient 0.1. Okay, and here material diffuse, material ambient, so we'll set the same value. Okay, so material ambient 0.0.1. Okay, and light ambient. Okay, so we'll try again. Far better. I believe I'll take another sphere. I have another sphere. Okay, so this is a smooth sphere. So this I am going to copy. Okay, so I'll take another sphere. It will be quite smooth. It has lot of kind of vertices. Okay, it is very big, so it would take some time to load it. Okay, is it that big? It took some time. Now result is smooth. Now I am going to set it on right side. Can we see now? The background is transparent now. Okay, and this can be situation of the moon. Now so nice. Can we see problem now? Now I am trying. This is the problem. Okay, so we solved one problem, but problem is still there. Okay, now this is crescent moon. This is what we want. Okay, so this is kind of crescent moon that we are looking for, but since this light is behind, okay, so if I want to see the real position of the light, then I can see this is real position of the light in -z direction. If right side, if I say it is -z, then light is behind the scene. See, it is right side. Light is behind the scene and it is generating the crescent. But behind the scene, it is showing the surface, the back of the surface. The back of the surface is being shown. Okay, so because we have not done any culling, so front of this sphere, what I mean is front of this sorry. Okay, I want to rotate only the light source, but somehow it is rotating everything. So it is perfect. Okay, let it come. Okay, so ambience will set green, a little bit light greenish we are seeing. So it should go away. Okay, shader eye children. So we'll make ambience as green. Okay, it will take some time, probably 5-10 seconds it will take. We have used a heavy light source sphere. Okay, it came. Now the idea is okay, so this is the crescent moon we are looking, but it is lighting the back side. So front side we are seeing it is transparent and back surface it is lighting. So back surface, I mean the front side of the back of the moon, so that is not visible, but back side of the moon, so that is getting lit, so that we don't want. So this is, we cannot create kind of this way, we cannot create a crescent moon. How it's possible? We want everything, this is what we want in the kind of a crescent moon. Okay, and now we don't want this area, so we'll cull the back surface. That is the solution. So that's why we brought this much discussion. So we'll enable the cull and we'll cull the back surface. So no back surface we want. So we'll try our luck again. Wow, this is the moon that we are looking. Okay, so this is importance of culling the back surface. Now the light is falling on the back side what of the sphere we are seeing, and that is not getting drawn because back completely we have culled. We don't want back. Okay, now This is day 1 moon, day 2, day 3, day 4. Okay, like this. And we have full moon. Okay, now we can see crescent down the line also. Nice one. Okay, so this is the crescent moon. Okay, so that we are able to see now. Okay, so if I make it up, full moon. Okay, so from right side also we can try. And we have crescent moon. Okay, so we saw all the three situations. Like ambience, we set it to black, then we set it to transparent, then finally we enabled the cull face and backside where the light was falling. So that face we culled it, and then we can see the crescent moon. Okay, so this is how cull facing face is important. Okay, so finally we achieved what we wanted to achieve. So we started with kind of a simple case of cull facing, where if we don't want Opengl to draw the backside of a polygon, then why to let it draw? Means it is not a kind of optimization. So for optimization, we remove the backside drawing, or if we are drawing the backside only and we never show the front side, then we can cull the front side. So with a simple example with the two light, blue light and red light, we saw that how actually it works. But the real case scenario, the case study, where we are like when we are showing like a heavenly body like moon or earth, where we show a few part of it that is lit through the sun, and then most of the part it is dark, then generally the light will be behind the scene, and then bigger part behind the scene that will be lit, and front side the part what we don't want that come into the ambience area. So that we deliberately we made it see-through, means transparent, but the side effect is that when the ambience is transparent, those surfaces they finally see the back side of the back of the polygon or sphere, and then there is nonsense. I mean, it shows weird kind of characteristics. So no one will come to rescue it there. So I would rather say that the developer or inventor who wrote the Opengl, so he had this in mind that in this kind of corner scenario where our front is transparent and then things from the back side is coming into the picture, then there can be a concept of front and back, and someone can cull whatever it wants. So whatever we showed in the example, so kind of one trivial thing that we modified the texture part. So if texture B equal to 1, okay, down the line it's a color part. So there the ambient we can set it to ambient underscore T, but it doesn't make much sense. Means it is not that changeable, because anyway when ambient T is 0, then we are making it transparent. When it is front ambient part, anyway it is very small. So it is negligible modification that may be required. Okay, but anyway, means this is what we tried to show, and we showed it. So we kind of binding up the cull facing scenario, and I hope that it was a kind of nice learning for the people. So please follow up with us, and we will bring many, I would say, complete things in 3D, and we saw that one shader program and one Python program, everything, whatever we showed that was recording, it plays also kind of animation. So we'll see more on it.